Welcome to this Hig-Mover Labs product informational video.
Hello, I'm John Higby. In this video, I'll be demonstrating initial setup and testing of our Hig-Mover miniature smart rotary actuator. Now these guys are compact rotary stages with motor, encoder, and driver electronics all built in. And this greatly eases systems integration by putting power and serial control over a single Ethernet style cable. Now to use our serial control, Hig-Mover Labs offers a full-featured Windows application and also an app for Android devices, which you would interface using our optional Hig-Hub bus master with Bluetooth radio. For applications with complex profiled moves, the Hig-Movers offer an industry-standard isolated step-and direction interface, which you can plug into a vast array of third-party motion controllers. Now, some things you'll need to get started are your Hig-Mover. You'll need a 24-volt DC power supply, which you can buy from Hig-Mover Labs. Every mover comes with one of these short pigtails. On one end, you can see we have a common Ethernet-style connector, and on the other end, we have this very small JST plug. This is what goes inside the Hig-Mover, and you can plug into either side. For this demo, I'm going to plug into this side. Let's plug that in. And now we have covers for these like you saw, but to save time, I'm just going to set that down like so. And what else do you need? You need a serial adapter cable. Now, you can get these from Hig-Mover Labs. We make these. It's got a serial port on one end that plugs into the USB plug on your computer. I've got that one labeled to COM4, and I already know that that's what it is. And the other end has this RJ45, this Ethernet style plug. So we've got our serial connection from the PC. We've got our 24 volts. We've got our Hig-Mover. We have to bring them all together into one connection. That's where this comes in. This is a power over Ethernet adapter. It's designed to combine power, like this 24 volts, with another connection, which in this case will be the serial link. And they're the same gender, so we need a coupler. And finally, those two are combined, and we plug the Hig-Mover actuator into the other end here. We've got our Windows application open here, and as I mentioned, the mover is on serial port 4. You can see it here in the pull down. I'm going to click Connect, and we're going to go to the Mover tab. And you see this button here, Refresh Mover List. This button pulls the serial bus for any movers that happen to be present. And we click that. Out of the box, the movers have their bus address set to 1. If you had additional movers, they would be numbered 2, 3, 4, whatever, up to 8. So we click on the 1, since that's the mover we have. Then you get this pause here while it uploads the various settings from the mover. Now we are going to click over here to Motor Enable, which is going to energize the motor. And now that I've done that, you can see that this is stiff, locked in that particular position. It's not fully stiff, it's a little bit detuned out of the box so that you can test it just lying on a bench like this. And now I can come over to a jog button and I can make it spin back and forth. Double clicking a jog button will keep it running continuously. Stop. You can also use the slider, forward or backward. The speed of the jog is determined by this number here. The user interface is currently set to degrees per second, so we got about 200.
This number here is the ramp time. The lower this number, the more gradual the ramp will be. 5 is pretty conservative.
This button here shows you the current position in degrees. We're set to degrees here, display. We're at about 167 degrees, and as I jog, you can see that number change. Watch what happens when I go past 360. After 360 degrees, wraps around through 0, starts going up again, and if I go negative, then it wraps back down below 360. If I wanted to accumulate the positions beyond 360 and below 0, you can enable that with this multi-turn button here. And now, if I jog past 360, it'll just keep going up higher and higher. And similarly, if I go negative below 0, the numbers go negative. So this is something you might want to use if you have multi-rotation kinds of applications. Now, we have a couple of slew functions. We can slew to an absolute position, or we can slew a relative distance. Let's go for the relative distance. Let me jog this thing to, say, a 12 o'clock position. And let's go slew 90 degrees to demonstrate that. Let's say for some logistical reason, you want to establish your own 0 home position. Let's say you want it to be at 12 o'clock as a 0 position. You click this button over here, Set User Home, and now that's 0. So if I come over here to some distance away, and then I come over here to slew to position, you see it's set to 0. Slew to position went to the 12 o'clock position. Now let's look at the limits. You can prevent the rotations from going farther than you want to in the negative direction and the positive direction. Let's say you've got some physical object you don't want to crash into, or you've got a bunch of cables you don't want to get twisted up. I want to set the negative limit here. I'm going to use the current position, which you can type in a limit if you want, or you can just click current position, and then that loads in the current position, which happens to be basically 0. We enable that limit. Then we want, let's say we want to use 360 as our positive limit. That number is already typed in there because it was in the mover default. So I click positive, set that positive limit to that, and enable the positive limit. Now let's say I try to jog forward. It will stop at the 360. That's where it hit the limit. Similarly, we go negative, stopped at 0 because that was the negative limit. So while we're looking at the limits, I'm going to demonstrate one other feature. I'm going to turn these limits off. I'm going to set the negative limit to 90. Set that. I set the positive limit to 270. And I'll set that. Then I'm going to hit this ping pong button, and you will see the mover run back and forth between the 90 position and the 270 position. Starts at the 90. There's the 270. Back and forth, ping pong, back and forth. It'll do that all day long until you either tell it to stop or you hit the stop button up here. Now I'm going to talk about tuning the servo inside the mover. And for this part of the demo, I've mounted the Hig-Mover actuator on a nice massive chassis so that it won't jump around on the table while we're doing this. And I've also put a payload on it. This is just a simple camera panner rig.
You see here on the lower right we have 3 slider controls: load, stiffness, and smoothing.
And so this is a slightly iterative process. And this is a very light payload, so we're not going to get much travel out of this load slider. But the basic procedure is you grab the load slider and you move it higher until you hear the mover start to make some noise like it's making now. And if I jog it around, you hear that it kind of buzzes and makes some a lot of noise. So I'm going to back it away from that setting. You can see that if I grab this, I can move it back and forth fairly easily, and this means that the mover will be less able to hit precise positions. So we're going to adjust this stiffness setting, which will give it a little more oomph in its various motions. And the same rule applies here. You dial it up until you hear some noise, and it hasn't really started buzzing yet. But if I jog it from here, there is a little bit of a buzz in there. I could, but you see, it's also gotten quite a bit stiffer. I could back it off a little.
The smoothing gain slider down here is in case after you've done your load and stiffness that you're finding your motion is still a little bit rough. The smoothing control and the damping control are discussed in more detail in our video on the 3-axis pan tilt roll camera head, where we discuss systems with multiple nested movers and mechanical components that are somewhat flexible or compliant.
Thank you for joining me for this product video. If you're interested in more camera applications, please check out our videos on our 3-axis pan tilt roll camera head.